All right, so label your notes. Section 5.1. The assignment that you had yesterday actually is 5.1 also, but I didn't feel like I needed to give you guys a bunch of notes on it. So we are going to move right on to 5.1, the derivative. Oh my gosh. I forgot how to spell derivative. The derivative of a natural logarithm. So let's just say that y is equal to the ln, I'm going to call it the ln of u, and not necessarily u in terms of the chain rule u, but sometimes you may have to use it in terms of the chain rule. So let's say you have the natural log of u, the derivative of the natural log of u, the formula that you use to find the natural logarithm is to take the derivative of u, and sometimes the u will require you to use the chain rule, but we'll get to those at some point. And you divide it by u. So you take the derivative of u divided by u itself.
That's all you have to do.
That's all you have to do. Yep, and some of these things will be so easy. Some of them are going to require you to do more work. We are going to revisit the product rule. We're going to revisit the quotient rule. Yes, I'm sorry. We are going to do all of those things. So, are you okay with that? You take the derivative on the top divided by the function on the bottom. Just the u part, not the whole function. Not the ln, just the u part of it. Are you okay with what I just said?
Yes.
Derivative on the top, the u on the bottom. All right, so example. Let's say we have, I'm going to have you find just a bunch of derivatives today. So I will write, derivative of 1 times, and after that I'm just going to give you some functions. Just assume that your job is to find the derivative. So y is equal to the ln of 2x. What's u? U is this part right here. So if you go back to the first page, we're talking about the ln of some function. So in this case, the function we are talking about is 2x. So what is the derivative of 2x?
2.
The derivative is 2. So that means that the derivative of y is equal to, what goes on the top?
2.
2. What goes on the bottom?
2x.
2x. Simplify, what do you get?
1 over x.
1. Make sure the x stays on the bottom. So the derivative is 1 over x. Wait. Yeah. Yeah. Go ahead. What up?
So the log you used to leave off then at that point?
Yeah. Yeah.
Is it the derivative on top or the u? The derivative.
Derivative on top.
Oh.
U prime right here. U prime on the top. So the derivative is on the top. The function on the bottom.
Oh, okay.
Okay. So you guys will get used to you'll start recognizing them pretty quickly, and you'll get to a point where you don't even have to do the u and u prime. You'll just right away recognize what it's supposed to be. All right, another example. Y is equal to the ln of x squared plus 1. Find the derivative. All right, what's u?
X squared plus 1.
X squared plus 1. What's u prime?
2x.
It is 2x. So the derivative of y. What's the derivative of y?
2x over x squared plus 1.
Very good. It's the derivative on top, 2x. On the bottom is the function x squared plus 1. It's u on the bottom. Can I simplify that? Can I simplify 2x over x squared plus 1? I can't do anything with x squared plus 1. I can't factor it. If the bottom was x squared minus 1, then you could factor it. It's still not going to cancel out with anything on the top, though. Okay, so this is it. Just 2x over x squared plus 1. All right, try another one. This one's a little bit harder. Not hard, just harder. Y is equal to x times the natural log of x. So the rule that I just taught you was for finding the derivative of the natural log of x, which this contains. It does contain contains a natural log, but there's an x out front. what are the x and the natural log of x doing? They're being multiplied by each other, which means to you that to find the derivative, you have to do what? The product rule. So the product rule says this. You take f of x, which I'll call this part, and multiply it by the derivative of g of x, which is the ln of x, plus g of x times the derivative of f of x. And I feel like we did the product rule enough that probably, I don't know that it will ever go away, actually. So let's do this. The derivative says you take f of x, which in this case is x, and you multiply it by the derivative of g of x, which in this case is the ln of x. So I'm just going to take a look at this part. This is the new part. This is the part you guys are learning about. So what do I call u?
X.
Call u x. What's the derivative?
1.
It is 1. So what is the derivative of the ln of x?
1.
X.
It is the derivative. It's u prime, 1, over x. Very nice. So it's x times 1 over x. That is just the beginning of the product rule, though, because the product rule says you take the original times the derivative of the second. I shouldn't say the original. The first times the derivative of the second. Now what? Plus the second, which is just the ln of x. You don't need to find the derivative of it. It just stays the ln of x.
Plus 1. I mean times 1.
Times the derivative of f of x. What's the derivative of f of x?
1.
It's 1, so it's that times 1. Yeah.
How come the first one wasn't just times 1? So I thought that was the derivative.
This first one right here?
Yeah.
Well, it's the derivative of the ln of x. The derivative of the ln of x is, remember how you had to do u prime over u?
Yeah.
So u prime is 1 over u, which is x. That's the derivative formula. So it's 1 over x. Okay? All right, so let's just clean this up a little bit. What is x times 1 over x?
1 over x.
Well, the x is like x over 1. So we're really multiplying x times, these two are getting multiplied, numerator times numerator, denominator times denominator. Yeah, everything cancels out. X times 1 is x, 1 times x is x, they cancel out, they give you 1. Plus, what's the ln of x times 1?
ln of x.
That is your derivative. Okay, another example. Y equals the ln of x to the power of 3. Now, if this was, what if it was just x cubed? Not ln of x cubed, it was just x cubed. What's the derivative?
3x squared.
3x squared. But because it's not just an x, it's an ln of x, what are you thinking right now? What does your mind immediately go to? The chain rule. Yeah. So what's u? In this case, what is u?
ln.
The ln of x. What is u prime?
1 over x.
Yes, it is the derivative of the ln of x. Do I need to walk through this?
No.
Are you guys okay now looking at the ln of x and knowing that the derivative of the ln of x is 1 over x?
Yeah.
All right, so u prime is 1 over x. So what I really have going on here is that y is equal to not the ln of x cubed, it is
1.
u cubed. Are you okay with that? Find the derivative of u cubed.
3.
Is 3, did I hear 3u squared?
Yeah.
Very good. But what do we have to do after we did that? After we found the derivative of this part, what did we have to do?
Multiply by the derivative.
But you want.
Yeah, you had to multiply it by the derivative. That goes back to a while ago. All right, so here we go. We have 3 times u squared. Well, what is u?
ln of x.
So we have 3 times the ln of x squared, but that has to be multiplied by the derivative of u, which is
1 over x.
1 over x. So one more step just to make this look a little bit nicer. It's going to be 3 the ln of x squared over what?
Over.
Yep, the x is on the bottom. This right here is over 1, so we go numerator times numerator, which is 3 ln of x squared, over denominator times denominator, which is 1 times x. Which is x. It's not horrible, right?
No.
I have 2 more examples. This first one is, I'm not going to say anything. This first, okay, let's go. Here we go. All right, so we have f of x, or y, whatever you want to call it. F of x is equal to the ln of, I'm going to erase that parenthesis. The ln of x times x squared plus 1 squared, all divided by the square root of 2x cubed minus 1. And I hope that when you are looking at this, you're going, seriously? He really wants us to do that? Because that looks horrendous. Quotient rule with powers, and then not only is there a quotient rule in there, but there's also a chain rule in the top, x squared plus 1 to the second power. That's a chain rule. This would be horrible. Is it doable? Yes, but it would be horrible to try to do without using some of the properties that we talked about yesterday. So let's use the properties we talked about yesterday, simplify this a whole bunch, and then we'll find the derivative, and you'll see that's a whole lot easier. So let's do a rewrite. F of x is equal to, all right, we have the ln of 2 things on the top that are being multiplied divided by something on the bottom. So when we're multiplying these 2 things in the top, you actually add them. So let's say this f of x is really equal to the ln of x plus the ln of x squared plus 1 to the second power. Or I guess you guys are right with that? Those are just the rules that we talked about, natural logarithm properties we talked about yesterday. But there's a divide, so when there's a divide by this thing on the bottom, I'm going to do a minus, okay, the ln of, and I'm going to kind of combine 2 steps in one right now. This is 2x to the power of 3 minus 1 to the 1/2 power. Okay, so I did the minus part of it, and I changed that square root to a 1/2 power. Are you okay with that? Okay, so now we've got a couple things we could do to clean it up. What else could I do to this to make it look a little bit nicer? Yeah, get rid of the powers. Not get rid of them, but move them. So I'm going to do, this is ln of x plus 2 the ln of x squared plus 1. So far, so good? Minus
1/2.
a half the ln of 2x cubed minus 1. Do you see what just happened? Nothing that I did was illegal. I did a really nice rewrite of the problem. And now I can find the derivative using my rule that we talked about on page 1 of our note. You take the derivative divided by u. So, go back to this. What's the derivative?
1 over x.
Very nice. You guys are already recognizing that the ln of x has a derivative of 1 over x. And by the way, why can I do each one of these pieces individually now? What makes me be able to do that?
Second logs.
I don't know that I heard it. I heard lots of things. Do you see the plus sign here? And the minus sign here? What I've done is created 3 pieces, and I know how to find the derivative of each one of those pieces because they are all nice, pretty natural logarithms. It's that plus and minus that allowed us to do that. Up here, when it was a divide, then you gotta use a horrible quotient rule. But this is really nice. Alright, so we have 1 over x. What about this? X, the ln of x squared plus 1.
What?
So I'm gonna put a plus sign, and I can't forget about my 2 right here, too. Don't forget that, 2. And then, sorry, ln of x squared plus 1. What is it? What goes on the top? 2x. The derivative of it, 2x. Divided by x squared plus 1. Minus, got a half here, times, what goes on the top? 6x squared. All divided by
2x cubed minus 1.
2x cubed minus 1. Alright,
Is that it?
I think up until now hasn't been too bad, but do you guys see where we've got lots of things going on now that can be simplified a whole bunch? So we've got 1 over x. What can I do here? Yep, we have 2 times 2x. That would make it 4x over x squared plus 1 minus what can I do with the 6x squared and the 2? Make it 3? I'm going to make that 2 a 1 really and make the 6 a 3. So I have minus 3x squared over 2x cubed minus 1. Ew. What can I do now?
Combine
You could leave it as is. But what else could I do? We should keep going. It would be fun, wouldn't it?
Yeah.
Correct.
What?
Common denominators?
We should, shouldn't we?
Yeah.
Yeah, Craig thinks we should. All right, good.
Squared.
Yeah.
Common denominators?
Yeah, now this is the deal, is we've got 3 different denominators. So my suggestion would be to let's just look at these first 2 terms and add them together. And you know what, we've been through this so many times, I feel like you guys should be pretty good at this. Cross multiply, 1 times x squared plus 1. That gets you x squared plus 1. Cross multiply this way, what's x times 4x? 4x squared. Divided by. Gotta multiply the denominators. So we have x times x squared plus 1. So far, so good? Alright, that's the answer to these 2 things being added together. Minus 3x squared over 2x cubed minus 1. And I don't want to start getting too messy here, so could I have someone read to me what I have right now so I can transfer it up to the top of the next page? First of all, can I flip pages? Is everyone caught up right now? No. Okay. So we've got an x squared plus 1 plus, it was 4x squared, right?
Yeah.
Over what on the bottom?
X cubed. I lied.
No, x times
Sorry. I took it from
x squared
X plus
Plus
1.
1.
minus
Minus
3x
3x
squared.
squared over 2x cubed minus
Okay, cross multiply again because we have different denominators. So we're going to multiply. Oh, actually, first of all, what should I do with this numerator?
Simple.
Okay, what is 1x squared and 4x squared?
5x
So we
squared.
have a 5x squared plus 1. So we have 5x squared plus 1 that has to be multiplied by what?
3x.
By
2x cubed minus 1. Got to multiply by this denominator, this one right here. Minus, now we got to multiply these 2. So I'm going to go x and 3 3x squared, that's actually going to get me 3x cubed times x squared plus 1. And then, of course, this all has to be divided by the two denominators. 3 denominators, 2 denominators, but first one came from 2. So we have x times x squared plus 1 times 2x cubed minus 1. Yeah?
So the x times x squared plus 1, could you distribute the x in?
Yeah, you could. And we're actually going to do it now in the numerator. Right here, we're going to distribute in. These two things have to be FOILed. Gosh, this is fun. 5x squared times 2x cubed, that's 10x to the 5th power. And then we have a 5x squared times a negative 1, that's a negative 5x squared. Then we have 1 times 2x cubed, which is 1, 2x cubed, and we have 1 times negative 1, which is negative 1. What'd you say?
10.
Oh, sorry. Alright, now I'm going to distribute that 3x cubed in, and that's going to get me minus 3x to the 5th power minus 3x cubed. And then all of this divided by x times x squared plus 1 times 2x cubed minus 1. And then we can just clean up the top a little bit. We have a 10x. What's the matter?
Why don't you distribute the x?
You could do that, yes. Sometimes, for some reason, it seems that the numerators usually are real polished, and the denominators are not always. So
How come you can't polish it, or how come you won't polish it with denominator?
I don't know. I don't know why.
Can you?
Oh yeah, definitely you can. That's not why it's not typical that the denominators are simplified. The numerators seem to be more simplified than the denominators. All right, so we have a 10x cubed and a minus 3x cubed. That's not cubed to the 5th power. 7x to the 5th power. And then we have a couple of cubes here, a 2x cubed and a minus 3x cubed. That gets you a negative x cubed. And then a minus 5x squared and a minus 1 divided by x times x squared plus 1 times 2x cubed minus 1. Now let's keep going. Just joking. I just want to say this, because it's Friday and I just thought it would be fun to do this. I would have accepted this answer right here. But that was fun. It was like a little Friday activity. This is as far as I went in my notes. I have one more example for you guys, okay?
What was the problem again?
What was the problem?
Can you go back?
No, you are. That's why it's funny. We were trying to find the derivative of the ln of that function. All right, one more.
Yes.
The only reason that I'm showing you this example, is that we have some absolute value bars in there, and I just want to mention to you that when you take a higher level calculus class, you will probably have to prove why this is the way it is, but for now I would just like you to accept that the reason that these absolute value bars are here is because sometimes the cosine value is negative, and you can't take the natural log of a negative number. But I just want you to know that when you do this, you are going to do everything exactly the same way that you would normally. So it's kind of like you can ignore that the absolute value signs are there. So I wanted to mention it because I know it's probably going to come up in your assignment. So what's u? We're taking the natural log of the cosine of x. What's u?
Cosine.
Cosine of x.
Oh.
What happened there? All right, so what's the derivative of u?
Negative sign. Negative sign.
Negative sine of x. So, derivative of what goes on the top,
Negative sine x.
negative sine of x, very nice. What goes on the bottom,
Cosine x.
cosine of x. Does that look familiar to you?
Tangent, something.
Close.
Sec square?
Actually, sine over cosine is tangent, isn't it?
Yeah.
You're right. I was thinking cotangent. I was thinking my answer was supposed to be cotangent, but I'm wrong. Sine over cosine is tangent, and it's negative, so it's the negative tangent of x.
That's it.
That's it. I'm done. That's it, you guys.
I thought it'd be a lot longer.
Yeah.